Alright, let's start again. So we were just finished talking about energy and energy transfer and using the specific heat capacity formula. Let's move now to a different kind of energy. So we're going to talk about kinetic energy and potential energy. Our question says, which of these is correct about an object that is dropped from the top of a cliff? So let's say, for example, that Alexa is standing on that cliff with her brother Chris, and each of them is preparing to drop an object. Let's say, for example, that when she's holding the object, what kind of energy does it have? It would have potential energy, gravitational potential energy to be exact. So what that means is, as she holds it and it has not begun to move yet, the object still has energy. If she releases hers while Chris is still holding his, then Chris's object maintains that potential energy. But Alexa's potential energy becomes kinetic energy as that object falls. So take a second right now to see if you can find the answer to this question, looking at the different answer choices and what you know about energy and energy conversion. So for this question, you should choose B as your correct answer. Because what B states is, as it travels downward, it gains kinetic energy and loses gravitational potential energy. So B is true for the simple fact that the kinetic energy is generated from the potential energy. One energy becomes the other energy type. In this example, we see an illustration of a simple machine. The statement above says a student pulls a lever down 4 meters. The lever lifts a box that weighs 20 newtons up a distance of 2 meters. So what's happening is she's pulling this rope down. She's going to pull it a total distance of 4 meters. The box is only going to move 2 meters. However, the box has a weight of 20 newtons. So this is kind of confusing because if we look at our formula for work, we know that work is equivalent to force times distance. So the question is, what is the actual distance the box is moving? And that answer lies in what is actually doing the work. As the girl pulls down on the lever, she's pulling down 4 meters. But what is actually touching the box is the machine, not the girl. So the girl does work on the machine, and in turn, the machine does work on the box. So the machine is actually doing the work here. So what we need to do is think about how far the machine is moving the box. In our statement, it says that the box moves 2 meters. So she pulls down 4 meters, but the box moves up 2 meters. So it's going to be 2 meters times 20 newtons. And when you multiply that together, you should get, for your answer, you should get B, 40 joules. So remember that when we talk about these machines make work easier through a force-distance trade-off. She has to move a greater distance, but her force is doubled. If you want to think about what's actually happening here, she only has to exert 10 newtons of force to move a 20 newton box. So her distance is doubled, but the force that she has to apply is halved. Alright, so next question. Which of these is evidence that electromagnetic waves do not require a medium? Take a moment to go ahead and look at those answer choices, and you can go ahead and try to answer that on your own. Okay, so each of these is talking about some kind of energy. We have sound energy, light energy, X-rays, that's another type of light energy or electromagnetic energy, and then emissions down here, the light from the sun. So here's the idea. When we are talking about X-rays actually can go through some human matter, and there are some parts of the human body that cannot be penetrated by the X-rays. This says light that cannot be seen through a solid wall. Sounds can be heard through a solid wall. But if you look at D is really talking about the absence of matter. If you go outside the Earth's atmosphere and you get into outer space, space is a vacuum. There is no air in space. Yet, however, the light and heat from the sun can still reach our planet. So the correct answer choice that you should choose here is D. This next slide is talking about atoms and the subatomic particles and how they are constructed. I'm not going to read this entire paragraph to you, but it is in the book, and I would suggest that you look over it and potentially print it out and highlight parts that you feel are most important. But the words in bold are the most important terms. It mentions protons, neutrons, electrons, it mentions a nucleus, it mentions electron clouds, and it mentions energy levels and electron shells. Alright, so let's just look at how those terms are related. What we have here is the nucleus of the atom. Inside the nucleus you're going to have the protons, you're going to have neutrons, and then on the outside of that atom you have a thing called the electron cloud. The electron cloud has different energy levels. So, you know, the electrons that are closest to the nucleus are in that lower level, and the ones that are furthest away are the outside. Those are called the valence electrons. So kind of going back here a little bit, it says that sometimes these energy levels are called electron shells. Alright? And again it mentions the protons, neutrons, and electrons. It talks about the charges that these subatomic particles have. Remember that the proton is going to have a positive charge. And it's the number of protons that's going to give us the atomic number. For example, neon has an atomic number of 10. That means it has 10 protons. Alright? In most cases, you're going to find neon as neon 20, which means that you're going to have a total of 20 of these particles here. 10 of those have to be protons because that's its atomic number. The other 10 would be neutrons. So protons have a positive charge, neutrons have no charge, and these little tiny things that are on the outside, to draw this more accurately, these would be so small you could barely see them, but these have a negative charge. The interesting thing is that even though the electron is so tiny and the proton is so massive in comparison to it, their charges are equal and opposite, meaning that one tiny electron can cancel out the entire charge of one proton. But going back over here a little bit, it talks about, in this image here, in this table, we see the different energy levels, so the first, second, third, and fourth, and the number of electrons that each can hold. So the first is very tiny, it can only hold 2. The second level can hold 8, the third can hold up to 18, and the fourth can hold 32. The important thing to note about an atom is the very farthest or outside energy level is the most important in terms of chemical reactions. Whenever there is a chemical reaction that takes place, the goal that the atom is trying to achieve, whether it forms an ionic bond or a covalent bond, every atom wants to have a complete valence energy level. And what that means is no matter what the number is from the atom's nucleus, it wants to have 8. Except in cases where there is only one energy level, and this first energy level is so tiny it can only hold 2. So 2 is a complete number if it only holds one energy level. So hydrogen and helium are both in period 1. They only have one energy level, so 2 is a number of completion, or a happy number, for those atoms. This talks about isotopes. An example would be carbon-14. An isotope is going to be any atom that does not have an equivalent number of protons and neutrons. Going back to this previous example, this is not an isotope because your protons and neutrons are equivalent. However, if I had neon 19, I would have one less neutron. So I would have 9 neutrons, 10 protons. That would be considered an isotope. So it says here, atoms that have the same number of protons, but different numbers of neutrons. The atomic, so basically you could say that neon 20 and neon 19 are isotopes of the same element, or versions of the same element. The atomic mass that you see listed on the periodic table is going to be the average of all the different known isotopes of that atom. Alright? Periodic table, it mentions how that was formed. When Mendeleev first created it, he organized it according to atomic mass. It was later on we discovered atomic numbers and protons, and we rearranged it, and it seemed to line up much better. What you're going to see on the periodic table is you're going to see repetitions of certain properties. So if you look at a certain group, if you go straight down, usually the atoms of those elements in that same group are going to have similar reactivity. The most reactive elements on the periodic table, group 17 and group 1, these are called the halogens. These are called the alkali metals. They're the most reactive. They love to form ionic bonds with each other. A great example of that is sodium chloride, NaCl. What we typically have here is we have our nonmetals on this side of the line, metals on the other side. This is hydrogen, doesn't really belong here. We place it there because it has one valence electron. The ones that you see here along the line that are shaded in that light gray color, those are going to be metalloids. So they're going to have some properties of metals, some properties of nonmetals. Sometimes they are called semiconductors because even though they will conduct electricity, they won't do it very well, or they will do it with a high amount of resistance. And by the way, when you talk about nonmetals, about half of those are gases at room temperature. You have the majority of these are going to be are going to be solids at room temperature, with the exception of mercury, which is going to be a liquid. All right, so this talks about fission and fusion. Memory aid, because you can get these very easily confused. This talks about a fissure, or the process of splitting. And fuse means to unite two things. All right, so remember, think about a rock that is breaking apart. When we have an atom go through fission or fusion, remember that fission is like breaking apart. All right, we get most of our energy if we're generating energy from atomic power or nuclear power, radiation. We're getting that through fission, not fusion. We do not have the technology to use this on Earth. All right, and this refers again to looking at those radioisotopes. So talking about those isotopes, sometimes those isotopes can become unstable, and if they are unstable, they'll go through this fission where they break apart. You have those alpha particles that are given off. Alpha particles are pretty big. Looks like a helium nucleus, 2 protons, 2 neutrons. Beta particles resemble an electron. They're much smaller. They're harder to block because they are tinier. And then you're going to have gamma sometimes, but gamma will always accompany alpha or beta. You will never have gamma occur by itself. All right, so looking at this, it says use the periodic table to determine which of the following contains 20 protons and 19 electrons. So you're going to need to access your periodic table for this exercise. Go ahead and try this question now, and then we will talk about the answer. So the most important part of this question is right here, 20 protons. When you see that 20 protons, that means it has an atomic number of 20. That when you look at the periodic table, you should look for number 20. Number 20 is calcium. It is an alkali earth metal, so it's in group 2. This says it has 20 protons and 19 electrons. Now remember, when you have a different number of protons and neutrons, that's called an isotope. However, here we have a different number of protons and electrons. So that's going to be an ion. So the correct answer for this question should be letter A. It is an ion of calcium. And that is true because the number of protons and electrons do not match. Look at this sample question. The half-life of cadmium-109 is 464 days. A scientist measures out a 256-gram sample. Approximately how many grams of cadmium-109 would remain after 1,392 days? Go ahead and use your calculator and calculate the answer to this question. Alright, so the first thing you want to do when you solve this is you want to figure out how many half-lives are in 1,392 days. So I'm going to put in 1,392 into my calculator, and I'm going to divide that by 464. When I do that, I'm going to get 3 half-lives. So basically what I'm doing right here is I'm going to take 256 grams, I'm going to multiply that by half 3 times. So I'm multiplying it by half 3 times. And when I do, I'm going to get 256 grams over 2 times 2, which is 4. 4 times 2 is 8. So now I need to solve 256 divided by 8, which gives me 32 grams. So your answer for this is 32 grams. So going back to how I solved this, just taking a step back, how did I do this? I looked at how many total days I had. Alright, so this is the total number of days as listed right here. Then I looked at how long a single half-life was, and it said a single half-life is going to be 464 days. So taking the total number of days, dividing by the amount of time in one half-life, that number gave me 3. So I had 3 half-lives. Take 256, multiply by half, multiply by half, multiply by half, and I get a total of 8. So 256 divided by 8 gives me 32. That is how you solve half-life problems. You are probably going to have at least 2 of those on your EOC. Alright, next question. The elements neon and argon are not reactive. These stand out at me because I know they're both in group 18, which are noble gases. Which hypothesis best explains this? Take a moment to go ahead and access your knowledge and attempt to answer this question. So, essentially neon and argon are part of a group of elements known as the noble gases. They're in group 18. All the elements in group 18 are non-reactive. Why are they non-reactive? And that is because they all have a full valence level of electrons. That means they all have 8. Except for helium, helium only has 2. Helium only has 2 because it only has 1 electron energy level. It can only hold 2 in that first level, so it is full. So the answer here is D. They have the maximum possible number of electrons in their outermost shell. We're going to stop right here for today. So thank you for watching, and we will continue with future videos to prepare for the EOC. Make sure you download the EOC study guide and access that. Any questions that you have about that or your practice questions, bring those to class and we will address those. Thank you.